Learn more, achieve more.
Okay, students, now we are going to start with the very important topic and most frequently asking topic. Okay, what is the topic? Oxo acids of nitrogen. And people are not getting this information from various books, even though it is mentioned in the NCRT, but people are it is not explained properly and completely. Okay, so just a word used oxo acids of nitrogen, then you have to completely go through thoroughly. Okay, so I am giving you all oxo acids of nitrogen, which is not available in single book. After referring many books, I have made this lecture, so it is a combination of few books. Okay, so let us start with the oxo acids of nitrogen. Okay, first one is hyponitrous acid. What it is? Hyponitrous acid. Formula is H2N2O2. So empirical formula, what it is going to be? HNO. What it is going to be? HNO. And what is the oxidation number? It is +1. Oxidation number is how much? +1. Okay. Second one is HN2O4. H4N2O4, hydroxynitrous acid. What is the formula? Hydroxynitrous acid. And this is also called as a nitrooxalic acid. It is also called as what? Nitrooxalic acid. Okay. And its oxidation number is how much? +2. So many acids are there. So I will try to explain to the maximum extent so that you should get through the all the questions. Okay. So don't think that only these three, few more are there. Okay. So hydroxynitrous acid, nitrooxalic acid, that is oxidation number is +2. And second one is HNO2, nitrous acid. What is the next one? Nitrous acid. This is most of the books given, and there are rare chances also asking questions on this one. Nitrous acid, and it is +3. Okay. Hyponitrous acid, hydroxynitrous acid, or nitrooxalic acid. Third one is nitrous acid, and these are the oxidation states. Okay, maximum whatever they can ask, I have covered this, and few more are there that also I am going to cover. Okay, so these are the three oxo acids of nitrous acid. Make a note of it, don't take a screenshot, just write down. On writing, that perfection will be different. Okay, inorganic, not only reading, you should also write down with your own hand, then only that goes into your memory. Okay, if you're taking screenshot and thinking that you have not studied, then it goes into phone memory and you will not be able to carry phone to your exam. Okay, so take this into your memory by writing down, if possible write 2 to 3 times, then it will give you good impact on your memory. Okay. Okay, few more oxo acids of nitrogens are here per nitrous acid. Okay, so you may see here structure I have written. Why not for others? Because this and this molecular formula is same. Only thing changes is oxidation number. So if I write this as a HNO3, so you will get confused. So for that purpose only I have written the structure. Okay, per nitrous acid. Per nitrous acid is also HNO3. But what is the difference over here and here is, here all the oxygens are oxide, O -2. But here two oxygens are there with -1 charge. Okay. What is that -1 charge? -1 charge, and it is -2. And it is +1. Okay. So if you count like this, then answer you are going to get. Answer you are going to get for this. This is per nitrous acid. Okay, sorry, it will be +3. Okay, So oxidation number of per nitrous acid, nitrogen in per nitrous acid is +3. Okay, even though oxidation number for molecular formula is same, but oxidation number will be different. In per nitric acid, I think you know it. Okay, then per nitric acid is HNO4. Here also oxidation number different because two oxygens are will be in the -1 oxidation state. In which oxidation state? -1 oxidation state. Okay, after studying the oxo acids of nitrogen, now we are in the oxo acids of phosphorus. Okay, here also structures are more important in comparison to oxo acids of nitrogen. So all of you listen carefully. One by one, we are going to discuss it along with the all aspects of phosphorus, of oxo acids of phosphorus. Now let's start with the oxo acids of phosphorus. Okay. Okay, now we are going to start one by one of the oxo acids of phosphorus. First one is hypophosphorus acid. And what is the formula? H3PO2. Like this, all entrance examination questions you will be able to answer. Okay, and you may not get all the information at one place in one book. So after collecting so many, after referring so many books, this lecture being prepared. So it will be beneficial for you instead of searching everywhere, and how the examination questions are going to come, that also I will explain. Okay, so hypophosphorus acid. Okay, formula hypo means less than the less. Actually, us means shows that it is a less oxidation number. So less than the less, it is hypo. Okay, so H3PO2 structure. Now, from this structure, if you are able to draw the structure, all this information, exam questions will be on this, but you should be able to draw like this. Okay, hypophosphorus acid. This is the hypo. What it is? Phosphorus acid. H3PO2. Three hydrogens are there, two oxygens are there. Okay. Now from the normal oxidation state only, here H3PO2. H3PO2 -2 into 2, it will be -4 and +4. Sorry, +3, and it is going to be +1. Oxidation state of phosphorus is how much? +1. Okay, and basicity will be decided by the number of OH. The very first oxo acid is oxo acids of phosphorus is hypophosphorus acid. Formula is H3PO2. Basicity is 1. Oxidation state is +1. This is the structure. Number of sigma bond, pi bond, hybridization. What will be the hybridization? sp3. Okay, 4 sigma bond, 1 pi bond. Anything they ask, you should be able to answer. Okay, are you ready? Next question. Next oxo acid. Okay. Okay, coming to next oxo acids of phosphorus, that is phosphorus acid, H3PO3. This is mostly available in almost all books. And the main thing is it is considered as acidic anhydride. Acidic anhydride, its anhydride is P2O3. Anhydride P2O3 means when you combine this like this, you will get 2 moles of this. 3 moles of water when combined with P2O3, you will get H3PO3. What you will get? H3PO3. See, if you multiply this with 2, then how many hydrogens are there? 6 hydrogens, 2 phosphorus, that is, and how many oxygens? 6 oxygens. 3 plus 3, 6 oxygens. So it's anhydride. Sometimes they may ask. Okay, P2O3. Actually, it will exist as a P4O10. How it will exist as P4O10? There are two oxides of phosphorus. I think you remember. I don't remember. P4O6, and sorry, this is P4O6 and this is P4O10. Okay, so here it is plus 3 oxidation state. This is this one. Dimer of this, it is P4O6. Okay, so here P2O3 is P4O6. Okay, So there are two oxides of phosphorus, P4O6 trioxide and pentoxide, phosphorus pentoxide and phosphorus trioxide. Okay, that structure and oxides will be different. Understood? So let us take to this oxo acids of phosphorus, that is H3PO3. It is considered as anhydride of. Its anhydride is P2O3 or P4O6, not P4O10. I am sorry that I written P4O10, but it is P4O6. Okay, this is the structure. Now I told you in the previous example, basicity is decided by number of OH. So basicity is how much? 2. Oxidation number you can calculate how much you will get, -6 and +3. 3 oxygen. So it is will be +3. Is it understood? And hybridization only is 4 sigma bond. So hybridization is going to be sp3. Second oxo acid, is it understood? Phosphorus acid. This is more important than the previous one. It is a acidic, its acidic anhydride is phosphorus trioxide. Phosphorus trioxide is P2O3 or P4O6. So 2 moles can be written like this. Why it is anhydride? I think now it is understood. Basicity is 2, oxidation number is +3, and hybridization is sp3. Okay, ready for next? Okay, coming to the third and most important, phosphorus acid and orthophosphoric acid are extensively available, extensively used. Therefore, the questions are very rare on this one. Okay, because everybody can answer, so they will not ask. Orthophosphoric acid is H3PO4. Likewise, its acidic anhydride is P2O5. There it was, you remembered P2O3. Okay, otherwise P4O6. Likewise, here it is going to be P4O10. This 3H2O remains as it is. Okay, basicity. What is the basicity? 1, 2, 3. So basicity is equal to 3. Oxidation state. If you can find out, you will get how much? +5. Then hybridization is sp3. Okay. Orthophosphoric acid, I think it is understood now. Okay. Ready for next? Next most important is metaphosphoric acid. Okay, its empirical formula is H3HPO3. What it is? HPO3, but normally it exists as a cyclic trimer. What exists as cyclic trimer? So this can be again same treated as acidic anhydride is P2O5, but in that I told you it is 3H2O, but here is only 1 mole of H2O. Okay, in H3PO3 taken thrice. I will tell you the technique, trick, easy method to draw the structure. Okay, first you make a beautiful benzene, but for this benzene, don't use carbon, use phosphorus and oxygen alternatively. Okay, what you will use? You will use phosphorus and oxygen alternatively. Okay, now is it understood now? Next. So we got how many? 3 hydrogens, 3 phosphorus, and 9 oxygens. Okay. Out of which 3 phosphorus we have used, 3 oxygens we have used. We got 6 more oxygens. What to do with them? So oxygen cannot take another oxygen. So obviously what we have to give? We have to give it to what? Phosphorus. Okay. And we got 6 oxygens, 3 phosphorus. So what we will give, try to give the each phosphorus 2 oxygens, so that nobody should worry, nobody should be excess. Okay. And 3 hydrogens are there. So who is there already? Bonds are over, so I will give 1 hydrogen to 1 oxygen. So this will be double bond, this will be double bond, this will be double bond. See how beautifully and easily without judicially. Judicially means everybody got their octet. Okay, and somebody like phosphorus can form 5 bonds. All 5 bonds are also complete. It is also happy. Oxygen is happy with 2 bonds. It is also fulfilled. Now you tell me, if the basicity of cyclic trimer they ask, what you will tell? You will tell OH, OH and OH. So basicity is how much? 3. And hybridization of each phosphorus, 4 sigma bonds, sp3. Is it understood? Number of pi bond, number of sigma bond, likewise plenty of questions will be there. And you can find out the oxidation number also or not. Okay, good. This is the fourth metaphosphoric acid made simple by VB sir. Okay, at VIJ CHEM. Next one, hypophosphoric acid. Okay, this is hypophosphoric acid. Okay, this is very well known for its complicated structure. Okay, actually one tetrahedral will be like this, another tetrahedral will be like this, upside down. What it will be? Upside down. Okay, and one sharing one corner of the tetrahedron will be this phosphorus, another corner of the tetrahedron will be this phosphorus. Okay, so that's why it appeared to be complicated. Now this light line, I think you can feel that. You can only feel. Understood? So this one and this one like this. Okay, hypophosphoric acid H4P2O6. This can be considered as acidic anhydride of P2O4. The speciality of this is here oxidation number you will find even number. In the examination, the question may be in which oxo acid of phosphorus even number plus 4 oxidation number will be shown. That time you should be the first person to reply accurately. Being VBS student, you should be the first person. Okay. Now, if the question is about what basicity, basicity is how much? 4. Okay. Oxidation number and all, you can do it or not. Okay. And hybridization will be sp3. Understood? Oxidation number already just now I told you plus 4 and basicity 4 sp3 hybridization. You cannot say complete as a tetrahedron. This is one tetrahedron, this is another tetrahedron. Okay, 5 oxo acids. Understood now? Okay. Okay, now we are in the last part, pyrophosphoric acid. What is the last one? Pyrophosphoric acid. Okay, H4P2O7. Simply it is like it was once upon a time. Once upon a time, 2 phosphoric acid was there. How many phosphoric acid was there? 2 phosphoric acid was there. One fine day, this water molecule removed, then it will become pyro. Pyro means anything which is formed by loss of one water molecule from two molecules. From two molecules, if you remove one water molecule, this is called as a pyrophosphoric acid. Okay. All this pyro, hypo, how it will be formed, what is its meaning, everything I explained in the 16th group oxo acid of sulfur also. Okay, that lecture was most appreciated lecture from the student community. After that only I am forced to make a video lecture on the oxo acid of phosphorus also. This is the oxo acids of phosphorus and these are the 6 oxo acids of phosphorus. We are in the last one, pyrophosphoric acid. Oxo acids of nitrogen also we have covered nicely, and depending on the importance I am giving you time. Understood? Oxo acids of nitrogen I have given less time, that means less important. Here I am explaining more means more important in comparison to oxo acids of nitrogen. Understood? So H4P2O7, how to draw this, what is the name concerned along with the, now I will start asking you question of basicity. How much it is? 4. Hybridization. Each hybridization will be sp3 sp3. Okay, they will be tetrahedron, but in this tetrahedron is connected to each other by one corner. What is the difference between previous and this corner was connected here in the previous one? There it was 6, now it is 7. One more oxygen increased. Okay, and oxidation number was plus 4 that side, and here it is plus 5. Understood? This is P2O4 dot 2H2O. Now it is P2O5 dot 2H2O. Okay. So basicity, oxidation number, hybridization, all thing over. And I expect all of you to make a good notes. I explained board wise board. Okay. But what you will do, you will take a good A4 size paper or a chart if possible. And in the landscape mode, you should write all of them together: name, formula, uh, basicity, number of P double bond O, number of OH, hybridization, oxidation number, all things you should write in one page. Then you will be getting clear picture. Understood? Because I have to explain, so every board I have to change it. Understood? That now I am bound to explain like this, but you are not bound to write it on a paper. So all of you will make a good notes and do well in your exams. Okay. So next, coming to the small topic, oxides of phosphorus. Okay. Oxides of phosphorus, and with beautiful explanation I am going to explain. Okay. So oxides of phosphorus are two: phosphorus trioxide and phosphorus pentoxide. Phosphorus trioxide and phosphorus pentoxide. First we will draw the structure of phosphorus trioxide. Okay. So how many phosphorus are there? 4 and 6 oxygens. Okay. So what I will do, I will connect like this: first a tetrahedron. Is it possible? Is it possible? No. Okay, so then what we will do, we will accommodate, because we got so many of oxygens or not. This is just like common sense. You should be able to satisfy all type of people. Okay, so then what I will do, I will write the oxygens in between. Okay, 1 2 1 2 1 2 1 2. Okay, then what you will do, you are left over with two more oxygens. So one oxygen will be like this, one oxygen will be like this. See how beautifully drawn. This is a structure of P4O6, and on each phosphorus there will be lone pair. There will be lone pair. This is P4O6. Okay. Now what is the next one? P4O10. Okay. So I am keeping it like this only because I am going to use it now. So P4O10. Now here when I compare here, I got 4 extra oxygens. So who will take the 4 extra oxygen? For phosphorus. Okay. This is nicely forming the coordinate covalent bond. Okay. Now nicely forming the coordinate covalent bond. Nicely forming the coordinate covalent bond. Nicely forming the coordinate covalent bond. Like this is the P4O6 now. Earlier, without these 4 oxygens, it is P4O6. When I add all phosphorus, this became P4O10. That is the oxides of oxides of phosphorus. So in this lecture, we have covered three very important topics. First, we have covered oxo acids of nitrogen. Okay, then we have covered oxyacids of phosphorus and oxides of phosphorus. Okay, all the three. Now you will be asking, what about sir oxide of nitrogen? That is specially done in the separate video lecture. Go to the 15th group playlist. There you will find all the lectures with the headings, which topic covered in which lecture. Okay. Bye. See you all.